Hi, today my partner Garcia Tobar Aslan Muriel and I, Per Garcia Eric Alexander, will talk to you about the Magnus effect in football. We are students of the ENP6 from Group CO5.
Have you ever seen in a football game how the ball forms a parabola in the air during a free kick after being kicked? This is evidence of the Magnus effect, a principle that depends on other principles such as Bernoulli's theorem or Newton's first law or law of inertia.
We have witnessed how the ball moves, describing a curved trajectory on more than one occasion. This is the famous Magnus effect, but what does it consist of? The Magnus effect implies the formation of a force on a rotating spherical body in a fluid that causes a deviation.
In the free kick, we know thanks to Newton's first law that the ball moves because the player gives it a force that gives to the ball speed and direction. However, the ball should move in the direction of the force. So, what causes the deflection?
So, we have a ball that is going to move around in a fluid. At this time, the ball will undergo a change of trajectory. However, we don't know what causes this deviation yet.
Going back to the Newton's first law, we know for sure that an external force is necessary to cause the ball to deviate in the form of a parabola. But where does this second force come from that curves the trajectory of the ball? Well, from Bernoulli's theorem.
The Magnus effect wouldn't be possible without Bernoulli's theorem. This principle tells us in summary that when a fluid moves with high speed, its pressure slows down, and vice versa. This applies to the movement of the ball.
When the ball moves through the air, the drag isn't the same at the two ends. In the direction in which the ball is moving, the drag slows down the flow of air, while on the other side the flow increases because the ball pushes the air.
According to Bernoulli's theorem, the region with high speed has low pressure and the region with low speed has high pressure. And here we find the force that deflects the ball for the Magnus effect.
When the ball is spinning in the air, the conditions of the Magnus effect are created. They are two airflows. On one side the airflow decreases by traveling against the rotation, creating high pressure, while on the other end the pressure decreases.
The region with high pressure gradually pushes the ball towards the region with low pressure, generating that characteristic deviation of the Magnus effect.
Finally, it must be remembered that the Magnus effect depends on other physical principles, mainly Bernoulli's theorem, and that this effect only occurs in sports that use balls, such as volleyball, basketball, baseball, tennis, golf, among many others.